Hi everyone, welcome to our lesson today on naming alkanes and cycloalkanes. This is called nomenclature. So you want to be able to have a molecule and know what to call it so you can communicate that with other people. So I want to show you this really cool application called ChemDraw, and professional chemists use this all the time. And the way that you can use that is to draw molecules. So I'm using the text tool. And I'm drawing CH4 and I'm using my chemical script here. So what I can do with this is I could draw it out, or I could convert its name. I can convert the structure to its name. So for example, if that's the molecule I have, it will tell me the name. So structure, convert structure to name. So anything that I draw that's in the database, it will be able to figure it out. So let's see how this changes as I grow the carbon chain. So if I had, let's say, another carbon, see how the name changed to ethane. And then if I grow it another carbon, now it's propane. And then another carbon, butane. Pentane, hexane, heptane. Octane, nonane, decane. These are probably prefixes that you've already learned before in chemistry class. And what I want to also do is teach you two more that you might not be familiar with. And that's undecane, which is 11. Like the French word for one is un, so undecane. And then another carbon, dodecane. So let's go back to our handout and we'll type in or write in all the names of these alkanes that we saw. What I want you to notice is that the ending of all of these is ane. Ane is for an alkane, so these are assuming that they're all single bonds and there's no double bond or triple bond in these. All right, so if you have a 7-carbon straight chain, then what would you call it? Using this chart, it would be called a heptane. Now let's draw a 1-carbon unit and record the names. So we have a 1, 2, 3, 4, 5, 6, and then we have a group branched off of one of the carbons. So first, I want to point out that these have 7 carbons total. So this is 7 carbons, this is 7 carbons. 1, 2, 3, 4, 5, 6, 7. When you have a straight chain, it's called N, and then for normal chain or straight chain, and then 7 carbons is heptane. But if we erase one of these carbons and you stick it on another carbon, you can have these branched alkanes. So let's figure out what they are. All right, guys, so I've gone back into ChemDraw and I've drawn these 2 molecules, and I want to find out their names. So I'm going to highlight the molecule on the left, convert its structure to name, and I see that it's called 2-methylhexane. So let's go back to our handout and we'll write 2-methylhexane. And when we tear this name apart, I like to actually work from the back forward. So our parent chain is a hexane. That means its longest continuous chain is 6 carbons. So I like to sort of highlight what is the longest chain. And it can be either this way or it could be this way. And either way, it's 6 carbons in a chain. So once I figure that out, then I want to know where's the branch on that. So if you notice, there's a branch either here or here, depending on how you highlighted it. So let's say this is my longest chain, then my branch is up here. Well, that's at position 2 if I number it from 1, 2, 3, 4, 5, 6. And then we have our branch at carbon 2. So at branch of 1 carbon is called a methyl group. Now meth, we saw that up here, methane. So that is the prefix for 1. F is the prefix for 2. If I had a 2-carbon branch, it would be an ethyl group. Okay, YL it means attached to. YL is referring to a branch. Okay, so just keep that in mind if you're referring to a branch. Add a YL suffix. So at the 2 carbon, we add a methyl group. Now here's something to think about. We could have started here on the end and done 1, 2, 3, 4, 5, 6. Then this would have been 5-methyl hexane. But the reason why we didn't do that is because there's a preference to keep the branches at the lowest possible number. 2 is smaller than 5. So we're not going to number it that way. So we're going to stick with the numbering in blue. Using that, what do you think this molecule should be called? Let's start with our parent. What's the longest chain? Count how many carbons that is. So I still get hexane as my longest chain, but I want to check to make sure, did I number it correctly? Is it 1 over here on the left or 1 over here on the right? Depends on where the branch occurs. I want the branch to be at the lowest possible carbon, so 1, 2, 3, or 1, 2, 3, 4. I want to number it the way that I have it. So, starting from the parent, this is a hexane. I want to draw that there's a methyl group that's a branch, and it occurs at carbon 3. I'm using a dash between numbers and letters. So 3-methylhexane. A 1-carbon branch then has a prefix of meth, and then we add YL, methyl. Okay, so if you've heard of methamphetamine, it's got a methyl group on that molecule. The numbers came from numbering the parent chain. That's the longest continuous chain. There's more than one way to number, but we choose the numbering in the direction that gives us the lowest number for the branching point. All right, let's take a look at this molecule now. And so what I have is a 1, 2, 3, 4, 5, 6 with a 3-methyl. So 3-methylhexane. And then I added 2 carbons to that chain. All right, so let's figure out what's the longest continuous chain now. What would you call the parent? Would it be a hexane, a heptane, an octane? What could it be? And then see if you have the branching correct and write out your name. All right, guys, so I have 2 different numbering systems, blue and red. And you can see either one works because the branch occurs at the 4 carbon regardless of which way you go. And our longest chain, I'll just highlight, our longest chain is this one. So we want that to be our parent chain. So a parent chain of 7 carbons has what name? It's a heptane, and we have a branch of a 2-carbon unit. So what kind of branch is that? That would be called an ethyl branch, and that occurs at carbon 4. The best name for this, using a systematic name, which we call IUPAC, for International Union of Pure and Applied Chemistry, they come up with the rules for this. So it's 4-ethylheptane. Go ahead and try this one now. Highlight the longest continuous branch and see if you've got the numbering correct, and then try to name it. All right, guys, so we're back with number 5 here. So I highlighted the longest chain, and it should be numbered the way that I have it. That gives us 2 ethyl branches at carbon 3 and carbon 5. So that means that I'm going to have 3 commas go between numbers. I'm going to say at 3 and at 5, so 3, 5 dash. And then something I didn't mention before was that we use di, tri, tetra. We use those prefixes that you've known before from covalent bonding. We use those if there's multiple branches, like 2 ethyls is diethyl, 2 methyl is dimethyl. You can use triethyl, trimethyl. Okay, so I'm going to bring in di, and I have to say both numbers. Okay, so 1 for one ethyl group and 3 for one ethyl group and 5 for the other ethyl group. And the parent is octane because there's 8 carbons in the longest chain. So now I want to see what you think would be the name if I just took off this group here and I had this molecule instead. What do you think the name should be in that case? So in this case, our longest chain is still 8, so it's still an octane, And now we've got two branches. We've got the ethyl group at carbon 3, and we've got the methyl group at carbon 5. So we're going to have a 5-methyl and a 3-ethyl. Now in the name, I usually do the parent first and add the branches before it. We want to go by alphabet. So in the name, it doesn't go by number, it goes by alphabet of the groups. So I have an E versus an M. E for ethyl, M for methyl. And we like to do this by alphabetical order. So E comes before M, so I'm going to do 3-ethyl, and then dash 5-methyl octane. So that's going to be the name of this molecule. So we like to order these groups alphabetically, regardless of the number. All right, so here's some practice with that. Please go through these. And then one note on these are where they give you the name and you come up with the structure. But there's something wrong with the names that they give you here. So draw them as stated and then correct the name and provide a better name than what they gave you. Okay, good luck with that. I'll post the answers. Okay guys, so here's what I get so far. I get 3-methylhexane, 4-ethyl 3-methyl nonane, 4-ethyl 2-methylhexane, 3,3-dimethyl octane, 2,2-dimethyl pentane, 4,6-diethyl 2-methyl octane, and then this one, we haven't learned this yet, so I shouldn't have put this on here yet. This is a branch you don't know yet, so we'll come back to this. Drawing these out, these are not the best names. The 4,4-dimethyl pentane, if you draw it out, should be number 2,2-dimethyl pentane. For B, if you draw out 1,1,1-trimethylbutane, you'll see that actually it's a 2,2-dimethyl pentane. You want to always do the longest chain. For part C, you have 2,2-methyl pentane. You need to say 2,2-dimethyl pentane. If you have 2 methyls, dimethyl, 3 methyls, trimethyl, assuming they're branches off the parent and not part of the parent. Okay, and then for part D, 2-dimethyl pentane is ambiguous. It can be 2,2-dimethyl pentane, like part C, or it could be 2-methyl pentane. It can also be 2,3-dimethyl pentane or 2,4-dimethyl pentane. So you can do any of those to correct that name.